Well, welcome everyone to today's webinar, Teaching Text Mining with JMP and JMP Pro. We have the pleasure of Ross Tussalum introducing us to this topic. For those of you who are not familiar, JMP has a lot of capabilities to not only analyze unstructured text data, but actually to import and format that data to get it ready for analysis. Ross is going to be focusing on the tools to analyze data, but just wanting to make you aware that we have a lot of capabilities of preparing data for analysis as well. And this kind of data tends to need a lot of that. Ross, are you ready to kick us off and go?
I am, Kevin. Thank you very
Okay.
much. And thank you, everybody, for joining us to learn a little bit about text mining in JMP and JMP Pro. Before we get started, I do encourage everybody to ask any questions that you have throughout. Kevin, who's hosting for us today, will be hanging out in the Zoom Q&A to answer any questions that can be answered briefly by text. And then also I will stop at a couple points throughout the demo today to take any questions that might be best answered by maybe taking a look at how to do something in JMP. So go ahead and pop open that Q&A panel to enter your questions at any point throughout the webinar today. So with that, let's head on over to JMP here and talk text mining. So we are going to today try to give you the knowledge that you need to teach text mining with JMP and JMP Pro effectively. So both in terms of actually just using JMP's text mining tools, but also some special tips and tricks with respect to classroom use and using these tools with students. And then also we will at the end review a collection of teaching materials that you can use to help either complement your course or lighten your load as you incorporate text mining with JMP into your syllabus. So before we get into the nitty-gritty details, let's just take a brief overview of where we're going today and some of the things that we're going to see. The first data set that we're going to be looking at is right here. It is from the United States Consumer Financial Protection Bureau. That's an office of the US federal government that's tasked with ensuring fair treatment of consumers by banks and other financial institutions. So these are real data here. I have 3,666 complaints that consumers have issued against their credit card companies. So if we take a look, let's say at this one in the second row right here, you can get a good idea of some of the unstructured text data that we have as part of this data set. So here is some text that somebody typed into an online form at the CFPB website to log a complaint against their credit card company. In this particular one, they were saying that they used an online tool to estimate their chance of being approved for a credit card, and that the tool said that their chance was good and they should apply, but ultimately they were denied the credit card and they believe that they were unfairly denied. So we have just shy of 4,000 different complaint narratives here against people's credit card companies. And today we're going to take a look at tools spanning the range of basic to advanced text mining methods. So on the more basic side, we'll see how to create word clouds like this one right here, where the size of the term or word reflects its frequency in the data set. So we can see in these complaints, people are commonly mentioning their balance, maybe being charged interest and making payments on that balance or interest. If you look just down into the left a little, you'll see fraud as another particularly common topic, or perhaps less common, but still important things like points or rewards. So this kind of word cloud, I think, is about the most basic text mining that most of our students are probably already familiar with, but we'll even go in the basic sense a step further and see how we can easily derive quantitative information from text data. For example, I've just saved a new variable back to my data table here, where there is a 1 if the complaint mentions the term rewards and a 0 if it doesn't. And we'll actually see that we can then use these new variables that we derive in statistical analyses that hopefully are already familiar to our students. So for example, I'll see how the presence or absence of the word reward predicts the ongoing dispute by the consumer. So this consumer disputed variable, which you can see right next to our indicator variable here, captures whether the customer was satisfied with the response from their credit card company, or they further disputed that response. So that is, they were not satisfied with how the credit card company handled their complaint. And if I click OK here, we can see over on the right in this mosaic plot with the purple representing the proportion of further disputes, we can see that it is slightly more common to see those disputes when somebody mentions rewards. And with our statistical test down here, it looks like we don't have a statistically significant result, though it is marginal, the p-value nearing that 0.05. So we'll see how to perform some of these basic text mining techniques here. We'll also move on to some more advanced techniques that are specific to JMP Pro. For example, latent semantic analysis and topic analysis. So what I have here is a new representation of both the documents and terms in our data. For example, I could find groups of semantically related terms. So in this case, maybe the term interest and balance and paid. And I think over here might be minimum. So we can see a group of terms that are showing similar patterns of occurrence across the documents, maybe suggesting some kind of underlying theme or topic. And we'll actually see how to derive these topics directly. For example, here we've detected a latent topic having to do with these interests, payments, balances. You can see other terms associated with this topic like minimum, full, statement, highest, due date. Whereas over here, we've detected a different topic that if you look at the terms associated with that topic, probably talking about things like rewards programs with terms like bonus, offers, points, miles, and so forth. So we're going to cover a range of different text mining techniques, but we're not going to see everything that you can do with JMP in terms of text mining, and that's just for the sake of time. So I do want to highlight, we're going to spend our time in JMP's Text Explorer platform, which you can find under the Analyze menu right here. And that tool has a number of different text mining capabilities. So in standard JMP, you have the basic capabilities, so computing your term and phrase frequencies, making word clouds, and also exporting term and phrase frequencies or these indicator variables like the one I just did to perform further analyses. And really, if you're just covering maybe in a single unit some basic text mining approaches, you could probably get by just fine with standard JMP. But if you're going to go into more advanced approaches, those will be found in JMP Pro, where, as we already saw a brief preview, we have latent semantic analysis and topic analysis. We're also going to see sentiment analysis today, the fourth bullet point there. That's a technique for quantifying the degree of positive or negative emotion in a text. And then there are a few JMP Pro techniques that we're not going to be seeing today. So document and term clustering, document classification, or term selection, which you might also hear referred to as text regression. That one is a technique for automatically selecting which terms are most predictive of some kind of outcome variable. So I just want to highlight that up front, that today we're going to get a good view of how text mining works in JMP through some examples like the one we're taking a look at right now, but we won't be covering every single technique. Though, of course, the JMP academic team is always available to help you learn how to use JMP and JMP Pro for any of the techniques we don't cover. So with that, let's actually dive into these consumer complaint data in a little more detail. And we're going to kick off with just some basic data preparation steps. So this really is the starting point for any text analysis, much like, really any statistical technique or machine learning method or anything like that. The quality of the data matters. If we put bad data through some kind of algorithm, we're probably going to get bad results out. Commonly said, garbage in, garbage out. So when preparing text data, we start with declaring things like stop words. So that is words that should not be included in the analysis. Common stop words include the, and, of. Also declaring phrases. So these are sequences of two or more words that commonly co-occur together. And also just cleaning up things like typos, for example. And so let's actually start there. It's probably the not the most exciting topic for our students, but one that nevertheless really needs to be covered to demonstrate how important it is upfront to get your data ready. So I'm going to go to Analyze Text Explorer to get us started here. I'm going to take the consumer complaint narrative column and put it into the text columns role in our launch dialog here. One thing you may notice, if you're familiar with JMP, you may know the modeling types and the little icons that designate them. So the red bars, for example, designating a nominal variable, the blue triangle designating a continuous variable. This icon that you're seeing here designates unstructured text, which tells JMP some special things about the data and what it can and can't do with it. If I right click on a column with text data and go to column info, you can set the unstructured text modeling type right here. And I recommend that you do that up front. It just helps JMP know certain things to do and specifically not to do with this type of data. For example, it won't attempt an analysis with this as a nominal variable with 3,666 levels, which could maybe bog our laptop down. When we launch Text Explorer, we have a number of different options for how JMP will tokenize the text that is split it up into its individual words. I'm going to leave everything at the defaults for right now and click OK. So what we're presented with is a summary at the top of all of our data, and then lists of the individual terms and phrases that occur most commonly in the data. Just to walk you through that top table quickly, number of terms is the number of unique words throughout all of the data that we have. You can see there are 9,740 in all. That's just the length of this entire list of terms that I'm scrolling through right here. Number of cases. Case is the word that we have for documents, or in this case, rows. So again, 3,666. Total tokens is the total word count across all of our data. So we have over 500,000 words of complaint data here. And the tokens per case then is just the average word count. So the average complaint is just under 147 words long. And we have down here showing us that we have no missing data. So that is no text fields here that were empty. So what we want to do first when preparing data is just get our term list ready to go. So almost everything we do in, let's get that back here. Almost everything we do in Text Explorer, though we'll see one exception later, will be based on the content of this term list using what is commonly referred to as a bag of words approach. So that is text mining techniques that don't take word order into account. And bag of words approaches have been common in text mining for a very, very long time. You will notice as you take a look at these, sometimes words that look like, or I should say terms that look like they don't belong in the analysis. So for example, we have 4 X's right here, and I might be curious actually what the 4 X's are. I can see that they occur almost 24,000 times in these data. So right off the bat, something to know for yourself and for your students is when you are looking at these lists of terms and phrases, it's very easy to get back to the raw data and see the use of these terms and phrases in context. To do that, just right-click on any item you're interested in and choose Show Text. It's the second option right here. So here, if I actually look at a few examples of these 4 X's, I can see that these are for redaction. For example, I have a redacted type of credit card here, or on, around, and then a redacted date right here. These are real data, and so the CFPB has redacted potentially identifying information here. So this is something I probably don't want to include in my analysis. It actually really carries very little information other than it's a type of personally identifying information. So I might want to add it to my stop word list. To do that, it's pretty easy. I can just right-click and go to Add Stop Word right here. And now you can see the total number of terms has gone from down 1 to 9,739, and that has been removed from my term list. And so to declare stop words or also phrases on the right here, the right-click menu is probably the easiest way to go. So as an example of a phrase, customer service, I think, is a good one. It's 2 separate terms, customer and service, but when somebody says customer service, we know that they mean that they were dealing with the customer service department at a company or talking to a particular type of representative from that company. So if I wanted to add this phrase to my term list, I would just right-click, and instead of going to Add Stop Word, I would just go to Add Phrase. And now here's a quick tip. If you wanted to find any element in your term or phrase list, you can right-click at the top of that table and go to Show Filter. So I'll do that. And if I look for customer service, you can see right at the top here, it's now part of my term list, even though it's multiple terms, and it occurs 437 times. Now, you probably also notice here that we have what appear to be some typos in our data. For example, horrible customer is lacking a space. We have customership. I'm not sure if that's actually a word in English or not. There are actually in any natural language data like this, probably going to be a fair number of typos or maybe slang or colloquialisms or other things that we might want to clean up. So in addition to declaring our phrases and our stop words, we may want to just apply some general cleanup via JMP's recoding tool as well. So for example, let's just take a look at account and all the different forms in which that word takes. So here we have singular versus plural, but we also have, looks like 5 cases where the space was not placed between the redacted information and the word account. We also have the with no space and account. So when we encounter messiness like this, we can clean it up quite easily as well, again, via the right-click menu. So let's just select maybe a few of these that we want to clean up together. I'm going to maybe grab these 4, and if I right-click and go to recode, I could, for example, just group these and say all of these should be recoded to just read account. And so I'll do that here. So the recode tool is another really powerful way to help clean up the data to actually increase the signal to noise ratio when we move on to perform some of our more advanced analyses. Now, you may have noticed when I did that actually that we combined account and accounts, so singular and plural. That's a very common type of recoding that somebody might want to do in text mining. Let's just take a look at another example. If we have, credit and credits, something like that, there is an option to have JMP do that in automated fashion for you. It's called stemming. Stemming is a technique that exists in many text mining tools. The general idea is to collapse or combine across multiple grammatical forms of a word. And if I go to the red triangle and term options, I can find a stemming option right here. So you'll see when I turn this on, and I'm going to choose stem for combining. I recommend using that as opposed to stem for all terms. And when we do that, you can now see that our term list has shortened. It's actually now just shy of 6,500 terms. And if I hover over, say, credit right here, it will show that it has combined credit, credits, credited, and crediting all into one meaningful unit for analysis. So with stemming, with recoding, with declaring phrases and stop words, we can go a long way into getting our data ready for analysis. That is, getting this term list to contain just all of the potentially meaningful units that we would want to analyze further. Now, I've been doing all of this via the point and click menus inside the tables themselves, but know that actually we do have some management tools under the term options submenu that you might find particularly useful. So if I go to term options, you're going to find tools for managing stop words, managing your recodes, managing your phrases, and so forth. Just to give you one example, if you go to manage stop words, you'll find the stop words that you have already declared local to this analysis. You'll also see the built-in stop word list that JMP comes with. So you can, if you want to declare stop words manually, easily type them in here and click plus to do it that way instead of actually finding them in your list right here. And pointing out that tool actually brings me to my first, I think, real specific teaching tip for the data preparation phase. And that is that if we are teaching text mining with JMP, we probably want to teach some of these data preparation steps because they're important and students should know about them when they get out there in the real world. But I don't know that we want to spend the actual amount of time it would take to clean up any individual data set. For example, declaring stop words and phrases and recodes for a data set of this size and complexity could take hours or days. So what we might want to do is actually prepare, let's say, a stop word list for our students to use when we move forward into other analyses. And we want to make sure every student has the, we'll say, the right or correct stop word list. There are a couple different ways to ensure that. So let me actually, I'm going to pull up a table script in which I've already declared a good number of stop words. You'll see that if we go to our management tools for any of these stop words, recodes, or phrases, when we have all of our locally declared, say, stop words, we have options over here for importing and exporting them. So for the sake of time, I won't show how it's done. I think it's pretty straightforward. You can export these lists to a text file, provide that text file to students, and then when they launch Text Explorer, they can click import and import those lists so that theirs match yours. This also could be helpful for student projects if students are collectively working on stop words and what they want to do is combine all of their efforts. they can copy and paste all of their individual efforts together after they export them and then import the final list. So you can use those management tools to help ensure everyone has the same lists, or you can also embed those lists directly into the data table before distributing it. So if I go back to that management tool one more time, you're going to notice that we have, in addition to the local list right here, we have something called the column list. So let's say I declared all the stop words that I wanted, and then I dragged them over to this column list and clicked OK. Back in the data table, if I go to the column info for our text column, you're going to notice I have a new column property that says stop words, and it contains the full list right here. Now, anytime I launch Text Explorer on this column, this stop word list is going to be applied automatically. So this, I think, for in-class demonstrations, maybe homework assignments or other things where you're going to just be directly providing the data set to students, I think might be the easiest way to ensure everybody has the right list. So that's all I have to say for data preparation at the front. Again, this is probably not the most exciting topic for our students, but one that we certainly want to ensure that they appreciate the value of, because again, just like any other technique, garbage in, garbage out. I see one question that has just come in. I'll answer it right now. That says, can you use the same list on multiple columns? And the answer is that yes, you can. So you could apply that list to any number of columns, either by copying and pasting the column properties. So you could copy the column properties for, let's say, this column and paste it into another column, and the stop word list would come along for the ride. Or another thing you could do, if you have a list that you just want to apply, let's say, for yourself every time, if I go back to manage stop words, you also have the user column. And so this will actually save your stop word list, if I were to move these over here behind the scenes, at the user level of your computer, your machine. So now across multiple data sets, that stop word list will apply. All right, so let's move on to talk some text mining basics here. By that, I mean turning text into basic quantitative information for graphing and analysis. And as we saw at the beginning, I think probably the most familiar and introductory way of doing this is to create a word cloud. So you're going to find the word cloud option under the display options submenu in the red triangle right here. It's the top of that menu, and then at the top of the submenu, we find it right here at show word cloud. You'll notice when I show the word cloud, at first it comes in this ordered format, which is nice because when two terms, let's say interest and company, are about the same size, the ordering tells me, in this case, that interest is more frequent than company or companies. But the word cloud has its own red triangle menu for customization. So you could declare a centered layout, which might be more familiar. And you can declare coloring as well. So if you go, all over the internet and find these word clouds, they're often given some kind of arbitrary color scheme in order to spice it up a little bit. But using some of these customization options under the red triangle, we can actually start to teach students to think about how the occurrence of certain terms might relate to other variables that we care about. So again, perhaps the consumer disputed variable that we have if you're looking off into the data table to the right here. So in the introductory example, you may have noticed that I didn't have these arbitrary colors. I actually colored by the values in that consumer disputed column. So let's do that. So I'll select consumer disputed, and maybe I had a different color gradient here. So let's go back to our diverging color gradient. Actually, let's see. I'm going to change the brightness as well so that we can start to pick out some of these words a little better. There we go. So here, reward pops out as particularly bright red. We also have report popping out and check. So red is associated with a greater probability of dispute than average, and blue with less. So we can start to by showing these word clouds colored by different variables, how we are essentially trying to relate this unstructured information to the structured or quantitative information that we might also have. And as we saw before, we can actually do this more formally by saving indicator variables to our data set. So what we did before, I'd found the term reward here, and I can just select that term and go to right click. You'll notice even in the word cloud, I have the same options that I have in the term list. So I could show text, for example, to see it in context. But I can, as we saw before, save that indicator variable back to my data table. So now I can use that as just a binary variable in another graph or analysis, as we did at the outset. So for the sake of time, I won't show that again since we already saw it once, but I think just honestly with the term and phrase list, with the word cloud and saving these indicator variables, you can get a long way into getting students to initially think about how text becomes quantitative information for graphing and analysis. Now, when thinking about just the real basics, like what we're looking at here, I do have a few tips specifically for teaching and classroom use. We just saved an indicator variable, which is one representation of the data that is taking the text and making it quantitative. When we're actually teaching this topic, we're probably at some point going to introduce the concept of the document term matrix. That is a tabular representation of the data, where we have one row per document and one column per term. And then the values in the matrix might be binary, like our indicator variables here. They might be the frequency of the term. You can save the full document term matrix to your data table to illustrate this to students. And you're going to find that option under the red triangle right here, Save Document Term Matrix. And it's going to ask you the maximum number of terms. So in this case, it is selected the number of terms that are have a frequency of at least 10. I might say instead, just give me the 100 most frequent terms. And then I would select the weighting. So binary will just give me ones and zeros, a 1 if the term appears, a 0 if it doesn't. Ternary will be 0 if it doesn't appear, 1 if it appears once, and 2 if it appears multiple times. We also have frequency, the log of the frequency, and then TF-IDF, which is commonly used. It's term frequency, inverse document frequency. So it's the frequency of the word scaled by how frequent the term is across other documents. So if I just stick with binary for now and click OK, you're going to notice that what happens is I have 100 new columns added to my data table. And in this case, it's just binary indicators of each. And many further text mining approaches utilize this basic representation of the data, where we have one column per variable, and we have either binary or frequency or TF-IDF weighting values in there. So this is the option you want to use if you want to actually directly illustrate the document term matrix to students. Now, another thing I think, even when we're thinking about basic text mining, is introducing to students or trying to illustrate to students the importance of all those cleanup steps that we will have began with. For example, the influence of stop words. If we're suggesting that maybe, you know, like I said before with a data set like this, spending hours or days cleaning up the data and getting it ready for analysis, we need to show, you know, the payoff, or conversely, what happens if we maybe weren't to do that. So let's see. I am going to show you how I might do that. Let's go back to our manage stop word list. We have all of these built-in stop words, and it says locked right here, but I also want to introduce you to the far right list, which is the local exceptions. And so the local exceptions basically say anything that is built in or at the user level or the column level, or maybe even, I guess, if you've declared it locally, will actually be reintroduced just local to this one analysis. So if I do that and click OK, you're going to notice that the word cloud has changed. I'm actually going to, why don't we just remove this coloring so we can see a little better here. And you'll see the word cloud here just gets completely swamped out by what really should be our stop words, I, the, my, and, to, and so forth. And perhaps by analogy, we could explain to our students how the more advanced techniques we might teach kind of have the same problem that we might have trying to see through the noise in this word cloud right now. So the fact that JMP, when you update your stop word list or your phrase list, automatically then updates subsequent graphs and analyses like the word cloud, can be useful in demonstrating the importance of these data cleanup steps. So that's what I have to say as far as just basic text mining. So that is just summarizing and turning into quantitative information for further analysis. Kevin, I'm going to take a moment and take a sip of water and see if you have any questions that we should field right now.
Just one, when you, in the initial list of words and phrases on the phrases side, there's a few that are in red, not there, but in a previous example.
Oh, sure. Yeah, sorry, I meant to mention that and it completely slipped my mind. So let's talk about it now. And you're seeing right now, I'm going to remove these local exceptions so we can maybe get some of those back. I will click OK. So here we have interest rate in red or identity theft in red. These are built-in phrases. So much like Jump includes a built-in stop word list, it includes a built-in phrase list. So anything in red is one that's built in. You see the ones in gray are ones that I've added manually. And then the ones that are in black are ones that still have not been added.
And then you kind of showing this when you were creating the document term matrix, but just asking about exporting those phrase lists. There's also a question about importing, which when you're showing that managing your terms, you can import those in. You were kind of showing how you were typing those in versus, yeah, there you go.
Sure. Yeah, so I showed just pointed out the import export buttons here with respect to the stop word list, but the same applies to your phrase list and also your recodes, any recodes that you've done. Any other outstanding questions before we carry on?
There's just a couple, but I'm going to be typing those answers to them.
Okay, great. Well, thanks, Kevin. Thank you, everybody, for the questions. We will now move along to talk about some of the more advanced text mining techniques like topic analysis and sentiment analysis. And again, as indicated in the journal to the left there, these are exclusive to Jump Pro. So I've made a bunch of changes here and there. Let me go ahead and get a clean version of this just to make sure we're on the right track. So again, I've just launched this from scratch, but this already has, if I go back to our term options, you'll notice we're back to our big stop word list here. You actually noticed before I added them to the column and I had not yet removed those. So now they're added there as well. All right, so let's talk topic analysis. And I should have mentioned at the outset, the reason that I've chosen topic analysis and also sentiment analysis for the advanced topics are that in my experience, these are some of the most widely used and most frequently taught text mining techniques. Again, they're certainly not the only ones, but you can go a long way with these two, both in the classroom and then out there in the real world as well. And so that's why I chose these two to demonstrate advanced techniques more generally. Let's begin with topic analysis. So in topic analysis, we're trying to, as we kind of saw at the outset, uncover some latent, that is, or unmentioned or unmeasured themes, which we call topics. And we do this via a more general technique called latent semantic analysis. Latent semantic analysis is essentially running principal component analysis on the document term matrix. If you're familiar with principal component analysis, it's a dimensionality reduction technique. If not, don't worry about the details too much. Just know that we are going to go to latent semantic analysis, SVD, to get started. So here we're going to talk about specify the number of terms that we're going to include in the analysis. So that is basically how wide of the document term matrix should we include. We'll also choose our weighting as we did when we exported the document term matrix. If you have good reason to change some of these defaults, by all means, go ahead. Certainly in an introductory class, some of this might be getting a little, I think, beyond maybe where our students are at. So know that you're typically going to get decent results if you have cleaned up your data well and use the defaults. So when I click OK, I get out at first these two plots that we call SVD plots. SVD is just the dimensionality reduction technique we've used here for latent semantic analysis. On the left, we have plots where there is a plot where there is 1 point per document. And on the right, we have a plot with 1 point per term. We already saw that if we go and highlight individual points in this right one, we reveal terms that in this new, the new dimensions that we've uncovered, we would say are likely to be semantically related. And we found things like interest and balance and paid. If we look into a different region of the plot, we can find maybe bonus and offers. And so now we're looking more at terms related to earning rewards with your credit card. And much like we can find semantically related terms on the right, we can find related documents on the left. So for example, if I were to take my lasso tool and maybe just draw a little circle around some of those in the top left corner here, I have a show text button that I can use to see what these particular complaints are all about. And it looks like somebody was booking a flight here using a Rapid Rewards credit card to purchase tickets. They're talking about annual membership fees. They're disappointed they're not allowed following the transparency of some regulation when they're using their Rapid Rewards card. Here we have another mention of using a card, in this case, paying the annual fee to utilize a bonus. So again, we're getting these fees, bonuses. Here's another mention of bonus down here. So it seems like we're probably dealing, again, much like we had in the top left-hand corner of the plot, with mention of these rewards programs. So these plots are good for exploring the data, trying to introduce students to the general idea of what we're doing. We're essentially detecting commonalities among terms or commonalities among documents. So detecting the topics themselves is the next step. We're going to find it under the red triangle right here, where we have topic analysis, rotated SVD. And so again, if you're familiar with principal components analysis and maybe factor analysis, you can think about this in much the same way. We're doing a rotation in order to find terms or get our terms to heavily load on some topics and not others. By default, JMP is going to recover 10 topics, but I could maybe choose a smaller number. And for teaching purposes, we might often choose to do so. So I'll click OK. You'll notice the different topics that we've uncovered. Topic number 1, in this case, we have, again, interest, balance, payments. So this is, again, people maybe disputing the interest that they've been charged, believing that they did make their minimum payment. Topic 2, we have bonus, spending, points, awards, offers. So again, that's those rewards. If we look over here, we can see for topic 3, reports, credit reports, the Fair Credit Reporting Act, or FCRA, certified letters. So this is people citing some maybe legal justification for their complaints. You'll notice with each of these short list of terms, you have loadings on the right. You can interpret these as the correlation between the topic and the occurrence of the individual term. So we would apply domain knowledge to interpret what these topics actually mean. But in these data, and again, these are real data, the interpretations do seem to be readily apparent, which makes this a pretty nice example for classroom use, in my opinion. So we have some other ways of looking at these data. Instead of just looking at these top term lists by loadings, one of the things I like to do is to actually, let's see, we're going to look at the word cloud by topic right here. And so instead of looking at a list, again, if we are, and our students are familiar with looking at word clouds, we can actually see words sized here, but now actually color-coded for their positive versus negative association with a particular topic. And so we can see, again, balance and interest popping up right here. In red, we see something like fraud. So it looks like maybe fraud is actually typically not talked about when people are talking about this topic. And so we can consume these lists in a more visual and perhaps more intuitive way with these word clouds. Now, if you want the full information, for example, the loading of every term on every topic, you could find that under the topic loadings table. If we are looking for the topic scores, so this is the score for each document of how much it is, perhaps we would say, about each topic. You can find it under the topic scores right here. And so, for example, row 2, the second one in the data set, which we started with, that was the person saying that they believed that they were unfairly denied a credit card after the online system said that they were likely to be approved for it. The strongest topic rating is topic number 4 right here. And if we look at topic 4, we see mention of credit score, credit limit, dispute, merchant, and things like this. And so that person talking about their credit score and credit report, their complaint was most likely falling here. Now, typically when we are working with topic analysis, much like in the example we saw with the basic text mining, we might want to actually work with these topic scores further. These topic scores might be associated with or predictive of other variables that we care about. And so you can always save these topic scores back to your data table. If I go to the red triangle here, you're going to find the option under Save Document Topic Vectors. And so now I have the top 5 topics, a score for each one, for each variable here, or for each document, excuse me. And so what I've done previously here is actually, I think in an example where I'd uncovered 6 topics, I've taken them and graphed the mean topic score for each based on distinction between whether or not the consumer disputed the company's response. And so you can see for, let's say, our rewards programs topic, you can see that there's a higher than average score in the dispute versus no dispute category. Same goes for ones having to do with credit reporting, and then also for legal issues. And we don't see the same distinction for people just disputing maybe their balance or interest payments, or saying that they're a victim of fraud, or maybe that they have a dispute with their credit score. So it looks like rewards reporting in these legal complaints might be those that are most predictive of somebody disputing their credit card company's response. Now, this brings me to a couple teaching tips for using this tool in the classroom. You probably notice in this graph, I have labeled all of my topics with some kind of general purpose conceptual label. That's again done just by applying our domain expertise in interpreting those top terms in each topic. You can actually code this into the Text Explorer tool itself to help students better interpret these things. So if I go to the red triangle right here, one of the options you're going to find is rename topics. And so I just get a simple text input for each one. And so maybe I would say this topic is for payment, and then the second one was for rewards programs and so forth. And when I click OK, those labels are actually placed into the report itself. And if I save those document topic vectors to the data table, they actually are stored as column headers. And so I really recommend using this rename topics option so that when we're working with these topic scores further, we always can easily anchor to these conceptual labels that we've given them. Now, one other thing I think not to miss is one of these graphs that we haven't seen yet that I think is particularly strong for exploring these data further in a classroom context. It's the topic score plots. And so we see in our score plots down here, we just have on the x-axis the topic score for each, and on the individual panes, we have our 5 topics with 1 point per document. And what we can do is use these to interactively select those documents which are most about or most strongly weighted on a particular topic. So if I wanted to find those documents that our analysis suggests are most strongly about rewards programs, I could simply just highlight some of them in the graph right here. You can actually see them being selected in the data table behind us in all of the other graphs. And then I can click Show Text to bring them up, and we can actually review these to ensure that our interpretation of this topic is accurate or appropriate. It's one thing to take a look at the top loadings by topic and figure or determine what we believe this topic to be about, but we should always verify by actually going back to the raw text and reading some examples. And this, I think, is the easiest way to do that, to just interactively select right inside the tool itself without writing anything back to the data table, those documents that we might want to review. So don't miss the topic score plot. And as it says in that bullet point in the journal, the topic score table is actually interactive as well. So if you make any selections in that particular table, you can also click Show Text to review those. So that's latent semantic analysis and topic analysis. That is the last we're going to see of this particular data set. Again, I think that this Consumer Financial Protection Bureau data set is a really great one for demonstrating a lot of different basic to advanced techniques in text mining. It's available freely online if you go to cfpb.gov, or I think it's actually consumerfinance.gov. That's right. You can find these and other data. This is just a small subset of data on one particular type of complaint. I will be posting this data set along with the journal with the recording for this webinar so that you actually have access to it. And it's government data, it's freely available, so you're free to use it in your course if you like. But with that, I do want to spend a few minutes here talking about another technique, and that is sentiment analysis, the quantification of positive to negative emotion in a text. And we're going to switch over to a different example. This data set, again, comes from the US federal government, in this case from the Federal Reserve Bank. And here we have data from what's called the Beige Book report, which is released 8 times a year and is a narrative report on the state of the economy in the United States. It's based on qualitative data, so things like interviews with local business leaders and experts and things like that. So if you take a look at the text of just one of these reports, this is one from the Atlanta District of the Federal Reserve from back in May 1970, actually. You can see that there's some emotional language right here. So the mood of our directors varies from pessimism to optimism. I mean, right off the bat, we have 2 emotionally laden terms, pessimism and optimism. And throughout these reports, there's a lot of language like that we could use to actually try to gauge what the overall sentiment or feeling is about the economy coming from the Federal Reserve board members here. And so what I've actually done, we'll take a look at where we're going to go, is perform a lexical sentiment analysis. So as this pulls up here, let's get our journal open. So in lexical sentiment analysis, we provide a score, in this case on an arbitrary scale of -100 to 100 for every document. This histogram right here represents the distribution of sentiment scores across all over 5,000 documents in this data set. So the orange are positive sentiment, the purple are negative. We can see that in general, we have more positive than negative documents. We can see any individual document down here. So as I make selections in our document summary table, you can see different text being pulled up below. And then in the text, you can see highlighted words that carry some kind of sentiment. So pessimism, optimism, weaken, pessimistic, adversely, another negative term there, and so forth. So in lexical sentiment analysis, what we do is declare a dictionary of sentiment terms. So each term gets some kind of score associated with it. And then the score for an individual document is just the average score across all of its sentiment terms. We can see that dictionary that I've applied right here. You can see there's a built-in dictionary actually that includes some basic words and even things like emoticons. But here's our dictionary. So for example, the term broken in this case gets a score of -60 on that negative to positive 100 scale. A phrase, can't go wrong, gets a score of +60, and so forth. And so using this dictionary, along with things like negation, so things like aren't or can't or not, and intensifiers, so those would be words that strengthen or weaken the meaning of the sentiment term. So for example, absolutely strengthens the sentiment, where almost maybe weakens it slightly by 0.8. We can then apply the scoring to any given document to arrive at the overall scores for each document that you see in the overall score column here and depicted again collectively in the histogram here. And so after scoring each document, again, to show that we can, by deriving quantitative information from text, begin to understand how the text relates to other variables, I've created this sentiment over time graph where we have 1 point per report here. We have a smoother representing, you can think of kind of the average across time, the average sentiment. That black line is at 0, so that's neutral. And we have these red regions capturing official time periods of recession in the US economy. And so you can see a pretty clear trend here where somewhere on the order of about a few months to a year to 2 before every recession, we see a decrease in sentiment in these reports. So it seems like the Beige Book sentiment is a reliable leading indicator of economic recession. So that's just a quick overview of what sentiment analysis is in JMP. Let's actually take a look at how to do it briefly, and again, some tips for teaching. So first off, we will, as we had before, launch our Text Explorer. I have our beige book text column as an unstructured text variable, and I'll put that into the text columns role and click OK. So Jump again has tokenized the text. You will notice in this case that I did not turn stemming on. And that's because in the context of sentiment analysis, we probably don't want to. For example, the term strong might, if we turn stemming on, get collapsed with strongest, but strongest is a more positive term than strong is. We might want to keep those separate and give them separate sentiment scores. So we leave stemming off here. You'll also find something that's kind of welcome, and that is that we don't need to declare stop words when launching sentiment analysis. And so if I actually launch that sentiment analysis, we'll see why. And you may have already intuited why. And that is because we start off our scoring with our sentiment dictionary, which we already saw here. So here's the built-in dictionary that hasn't been customized at all. And any term that doesn't appear in the dictionary is functionally a stop word. So we really don't need to worry about, say, kicking out words like the and. As long as they don't have a sentiment score, they don't affect the results. But just like our previous examples, we still have some preparation to do before we can interpret our results. In this case, it's all customizing the dictionary, the sentiment terms, the intensifier terms, and the negation terms. And we can do that a number of different ways. We can do it interactively in the text itself. So for example, if I wanted to add that term optimism that we see in this example, row 1 down here, I could just hover right over it and say I want to give that a score of, let's say, positive 60. Jump is going to automatically rescore every single document to account for that. So you can see it's actually doing that right here. Optimism has been added to our list of document sentiments for that document, and it is now in our list right here. So if I get down to the O's, you will find it right here with that score of 60 that I entered. Now we have these shortcut buttons, which you see here and also down at the bottom to add scores of particular values. So positive or negative 30, 60, 90, but you can declare any score you like by just typing into the sentiment terms here. So I'm going to go ahead and type 50 and click enter. And that's going to apply that score now across all of our documents to get optimism in this case to match optimistic. Now, in addition to this interactive way of declaring our sentiment terms, and you also notice when I hover, I have the option to add negators and intensifiers as well. We have management tools, much like the stop word and phrase management tools that we saw before. So if you go to the red triangle, you'll find those tools right here. For the sake of time, I won't demonstrate them now. They look exactly as the ones that we saw earlier for stop words and phrases. Now, one thing you may have noticed up in our sentiment term list is that we actually have this list of possible sentiment terms. So this is a handy way to start to build out a sentiment dictionary. Jump is serving up for us terms that seem to co-occur with other terms that themselves frequently co-occur with terms that are in our dictionary already. So for example, we might find the term strong, which is a particularly common word to designate a healthy economy in these reports right here. And so now if we look, we can actually find, if I can scroll back down here, I won't, for the sake of time, try to search it. Oh, well, actually, no, we do have the time. Let's see. So we can find that we've added strong and, in fact, strong with both our intensifiers and negators have been applied automatically so that we get things like not extremely strong, getting a score of negative 100. Or let's see if we go down to our positive versions here, strong, over strong, or overly strong. So all of these things are being applied automatically. And for any of these, let's say if we wanted to see the occurrence of overly strong in context, we can just select it in that list. And we will find the example in the text pane down below right here. So we would typically go and declare our sentiment and intensifier and negator terms. And then once we are ready to go and want to export our sentiment scores for further analysis, we have that option under the red triangle right here for saving document scores. And that is how I got the scores out to make that timeline that we saw earlier. Now, a few teaching tips for teaching sentiment analysis. Just as we want to ensure students have the right or correct stop word list when we do, say, latent semantic analysis or topic analysis, we might want to use the data management tools or that column property option to declare our dictionary terms. And so you can, just as we did with the stop words, for example, you can do the same things with your sentiment, negator, and intensifier terms. For the sake of time here, I won't demonstrate how to do that. Another thing is to make more clear how all of these scores are being calculated. So for example, document number 1 right here has a score of -36. And for our students who might say, well, where does that really come from? I understand it's kind of based on these individual words that are being highlighted in the document here. Well, you can always just hover right over and it will show you the calculation. In this case, we get our score for every single sentiment term that appears. There are 9 of them in total. So if we take the average, that average is -36. Same goes for the application of negation and intensification. So for example, if I want to know how remarkably strong right here gets a score of 90, I can hover over it and see that strong has a baseline score of 60 times 1.5 for remarkably gives me 90. So there's some nice hover help here to help students understand how these scores are being calculated. And then finally, one thing I just want to mention, when you launch sentiment analysis for the first time, you're probably going to get a little progress bar that says parsing documents. And what that's doing is actually parsing the syntactic structure of these documents to try to get negation and intensification right, to apply them more accurately. And you'll find it turned on by default right here, parse documents. The parses, that is the syntactic structures, will get cached to your computer, and depending on your operating system settings, will stick around for a while. Mac, I believe they hang out for 2 weeks. But I bring this up really to say that if you have large data sets, the parsing involved in sentiment analysis might take a few minutes. And so I'd run that before class so that when you are in class and launching sentiment analysis, the parsing is already done behind the scenes. Otherwise, you might sit there and wait for a couple minutes. So those are just a few teaching tips on teaching sentiment analysis, and that's the last text mining technique I want to cover today, before briefly mentioning just a few teaching materials that you might be interested in. First, where to find some text data sets. I'll be providing the examples that we saw today alongside the recording, and you'll all be receiving an email with a link to that. Under our sample data index, we have a text processing section. So if you go to help sample data, you'll find some additional data sets there. I also have listed, and you can reference these later, 2 places where I have gone in the past and found a large amount of often pretty interesting text data. So if you're familiar with the University of California Irvine Machine Learning Repository, you can search that for text data. Same goes for Kaggle. They run data science and machine learning competitions, and they have a large number of text data sets posted there as well. If you are looking for maybe some quick tutorials to help teach your students, for example, how to clean up and prepare their data in Text Explorer, or how to perform some basic text analyses, we have a couple videos available in our learning library. So if I go to jump.com/learn, we'll land at the learning library, which, if you're not familiar with it, is a collection of just over 100 quick tutorial videos and PDF guides on how to do specific things in JUMP. And you'll find under data mining and predictive modeling, if I can get myself to stop scrolling here, 2 videos right here for describing unstructured text, which is your basic text mining and text preparation, and then also the analyzing unstructured text. So that's getting more towards the, say, latent semantic analysis that we did before. And so you'll notice if I click on any one of these, I just clicked on describing unstructured text, it's going to pull up a quick tutorial video, this JUMP demo, and you have a link right here in the orange button to a 1-page PDF guide that summarizes the content of that video. If you're looking for maybe additional examples beyond those I just showed you today, I would recommend checking out in our case study library. So that can be found at jump.com/cases. The text mining cases available. Right now, we actually have one. For the sake of time, I'm just going to Control F my way to it. If I search for text, you're going to see that we have a case study of text exploration of patents. If I click here, it'll take us down to it. And we can see that here we cover word clouds and other data visualizations for text data. And then actually one of those techniques that we didn't cover in the webinar today, term selection. So if you click here for the PDF, you'll get a PDF that describes a text mining problem, provides a step-by-step solution path with screenshots and JUMP instructions, and exercises for students to do for homework. So we have this case study available, and also in development right now, a sentiment analysis case using that Beige Book example. So stay tuned for that. And then finally, I see we've hit the top of the hour. So I'll just briefly mention, if you're looking for a textbook that covers both text mining and specifically with JUMP examples, I recommend looking at the book Machine Learning for Business Analytics, the second edition with JUMP Pro. That was released somewhat recently. It's a very popular and widely used book in business analytics courses in general. Covers a wide range of techniques and now includes a chapter on text mining that covers the basics and the document term matrix and also latent semantic analysis, and with JUMP Pro examples throughout. But anyways, thank you everybody for sticking around till the very top of the hour to learn hopefully really everything you need to know to be able to teach text mining with JUMP and JUMP Pro effectively. I'm going to hang out and answer whatever remaining questions that we have. And again, just remember, you can always reach us at academic@jump.com with any further questions or needs. So Kevin, I'm going to stop and take a breath and sip of water and see what questions we might have to address on our way out here.
Yes, there's one question from one of our guests, Ashley. She was asking, and I think the answer is it doesn't affect this, but maybe you would know, is when you're getting in there with stemming and stop words and all that in the initial term list, is that going to affect what happens with sentiment analysis? So that if you combine strong and stronger by stemming, but when it gets to sentiment, would it treat strong and stronger as different?
Let's see. So I don't want to provide a definitive answer to that question because I'm not sure exactly how it would behave. I know that in general, because of the fact that sentiment analysis has this dictionary and might have different needs with respect to what counts as a stop word versus some other analyses, that there were some special considerations in keeping it operating separately from some of the other analyses you might be doing where, say, the stop words actually matter. So I would say test it out to see how that behaves. And in general, my advice is do sentiment analysis in a separate Text Explorer instance, just to ensure that you're getting the behavior you want. I personally would not combine, let's say, latent semantic analysis and sentiment analysis in the same Text Explorer window.
Yeah, I think this actually gets at, Ross, what you were saying at the beginning is what separates text analysis from sort of typical analyses on numeric data is there's so much curating and managing, and I think you've made the comment that you can spend days on it. There is so much stuff of like, okay, I want to load up my own dictionary. I don't want to include these. I want to combine these. And in one application, a word is a positive meaning, and then in another application, that same word could have a negative meaning. So this process does take a lot of manual just curating and really massaging this in a way that numeric data doesn't have at all.
Yeah, that is certainly the case. See, do we have
someone asked about Spanish? Yes, you can. So this is the whole thing with dictionaries is you can load up your own dictionary of words. So if you wanted to bring in another language, you can do that.
Oh, for sentiment analysis?
Well,
in general.
Yeah, in general, yeah.
Oh, sure. Yeah. So Text Explorer actually supports a number of different languages. I didn't cover that here. And that was, given that we have an international audience, I apologize greatly for that. I should have pointed out that we have support for all of these languages in Text Explorer as of now. That said, for sentiment analysis, as I mentioned, it actually syntactically parses the text to apply intensification and negation more accurately. That runs an English-specific parser. As of right now, we don't have parsers in other languages. So sentiment analysis, you can create your own dictionary in another language and apply it, but you may find that the negation and intensification isn't as accurate as it would be with that parsing. If you would like to see parsing for other languages, go to community.jump.com where you'll find the wish list and you can make a request for that.